Last question then is trigonometry. So first a show that question and then a solving equations. So show that. Let's start with the left-hand side. You can start with either, but I'm going to start with left-hand side. And I'm going to, first of all, switch any tan in terms of sine and cos, because on the right-hand side we only have sine. So tan theta I know is equal to sine theta over cos theta. And therefore plus 2, 1 over tan theta is equal to cos over sine. So that's the same as 2 multiplied by cos theta over sine theta. Then if I expand the brackets, multiplying by cos, the first term will be just 3 sine theta. Cos divided by cos is 1. And the second term will be 2 cos squared theta over sine theta. I only want in terms of sine. On that right-hand side, I only have sine theta. I don't want any cos theta. So this term is fine. But I know, because of the identity sine squared theta plus cos squared theta equals 1, I can rearrange that to make cos squared theta 1 minus sine squared theta. So this is now 2 multiplied by 1 minus sine squared theta, all divided by sine theta, so I'm getting closer. 3 sine theta, let's expand the brackets, so plus 2 minus 2 sine theta over sine theta. If we split up that fraction, that becomes 2 over sine theta minus 2 sine theta over sine theta. So then we've got 3 sine theta. I've missed out a squared, haven't I? This should be squared here, and this should therefore be squared. So plus 2 over sine theta, and then this simplifies just to 2 sine theta. 3 sine theta minus 2 sine theta is just sine theta. And therefore we have proven, so equals to right-hand side. There's a few different ways you can do that. That's just the way I would go with it. And then part B, hence solve in radians now. So your calculator needs to be changed to radians. Solve. That expression is the same as this. So hence means use your answer from before. So instead of that complicated expression with cos and tan, use the one that only has sine in, equals 4 sine x minus 5. So I'm going to change that left-hand side to what we've got there. Sine x plus 2 over sine x, and that's equal to 4 sine x minus 5. Okay, I don't want this fraction if I'm trying to solve, so I'm going to multiply everything by sine x. That gives me sine x squared plus 2 equals 4 sine squared x minus 5 sine x. Then this looks like a quadratic, so one side needs to be 0. I'm going to make the left 0. 4 sine squared minus sine squared x is 3 sine squared x minus 5 sine x minus 2. So does this factorize? I think so. So 3 sine x and sine x. So it must be 2 and negative 1 or negative 2 and 1. I think this is going to be negative 2 and plus 1 equals 0. Yeah, minus 6 sine x plus 1 would be minus 5 sine x. So that means sine x can either equal negative a third or sine x can equal 2. This cannot be true. The maximum sine x can be is 1, so there are no solutions there. So therefore we have to use this. So we need to do inverse sine of negative 1/3 to get our principal value in radians as well. So negative 1/3, that gives us negative 0.3398 to 4 significant figures. We want between 0 and 2 pi, greater than 0 but less than 2 pi. So you can think about the graph or you can think about the cast diagram. 0, pi over 2, pi, 3 pi over 2, and with negatives, this would be negative pi over 2 going backwards here. C-A-S-T. So negative 0.3398 is less than negative pi over 2. Greater than negative pi over 2. So I know it's in this quadrant here. It's between 0 and negative pi over 2. So this angle here is 0.3398. That's when sine is negative in this quadrant. So the other quadrant where sine is negative is here. So this is 0.3398. So if we start going around anti-clockwise, the first angle we get to is pi plus 0.3398. And the second one we're going to get to, this is 2 pi here, so 2 pi minus 0.3398. All the others will be outside the range. So if we work those out, those should be our only two answers. Pi plus 0.3398, 3.48. Does it say how many significant figures? 3 significant figures, so that's fine. And then 2 pi minus 0.3398, 5.94.